In the relentless pace of modern industry, efficiency and durability, those are just table stakes.
Absolutely.
But absolute, uncompromising reliability, that is the real currency. You just cannot afford a failure in these complex systems that power, well, everything.
And it's fascinating because the reliability of some 1,000-ton machine often comes down to a component you can literally hold in your hand.
Right.
We think about these massive turbines or data centers, but the nerve center of all that is usually tucked away in a control panel.
Exactly. And that brings us to the surprisingly critical material at the heart of today's deep dive.
Yeah.
The aluminium tube. We've synthesized a whole stack of your sources detailing its rapid and undeniable rise in the most crucial industrial areas, specifically in organizing the wiring of those control panels and, maybe most critically, in manufacturing electrical lugs.
So our mission today is really to figure out what fundamental qualities make aluminium the champion right now in these really high-demand environments. We need to unpack how it's replacing traditional, heavier materials like copper, especially when engineers have to balance performance against, weight and cost.
And the initial core takeaway, the big insight from all the sources, is this. Aluminium's inherent qualities, that amazing lightweight strength, its excellent conductivity, corrosion resistance, and of course its cost-effectiveness. These aren't just market advantages.
No, not at all.
They're actively driving these huge global trends, especially towards green manufacturing and the modernization of our sustainable infrastructure. This material isn't just following the shift, it's in many ways powering it.
Right.
Okay, let's unpack this. Before we get into the application, we really have to look at the material itself. What makes this versatile extruded metal so critical for ensuring, seamless current flow and reliable system performance?
We have to start with the fundamental properties. They just offer this unique material advantage. And the first thing engineers always talk about is the strength-to-weight ratio.
Okay.
Aluminium tubes, they're hollow sections, but they are incredibly strong for their mass.
So think about a dense industrial control panel assembly. I mean, it's just packed with components.
Yeah, totally packed. So using aluminum tubes for wiring conduits or internal bracing, it means the system keeps its durability, but it's dramatically easier to install, to ship, and to maintain.
Right.
One analysis we looked at suggested that in large-scale electrical projects, just switching the conduit material can translate to logistics savings in the tens of thousands of dollars.
Just from the weight.
Just from the reduced weight on site, yeah.
Yeah, that makes perfect sense. You get all the support you need, but you avoid the logistical nightmare of heavier materials.
But this is where my inner skeptic, acting for you, the learner, kicks in.
Okay.
If copper has superior electrical conductivity, why make the switch? Doesn't the lower conductivity in aluminium mean you need a thicker tube, which ultimately cancels out the weight savings?
That is the absolute perfect question, and it's the key trade-off that modern engineering has really solved.
Yeah. So yes, copper is the gold standard for conductivity, no question. Aluminium needs about 1.6 times the cross-sectional area to get the same resistance as a copper conductor.
So it does need to be bigger.
It does. However, and this is the key, aluminium is only about a third of the density of copper.
Oh, wow.
So even when you make the tube wall or the conductor thicker to match that resistance, the component is still significantly lighter, often 40 to 50% lighter than its copper counterpart.
So you're still coming out way ahead.
Way ahead. This means in high-demand applications like long-run electrical distribution, you optimize performance and get dramatic weight reduction and, crucially, massive cost savings.
So we win on weight, we win on cost, and we hit the performance threshold we need, just with a little more volume. That feels like a clear victory for industrial use.
It is. And then you add the longevity component, which is critical in these industrial spaces that are, rarely climate controlled and are often pretty harsh.
You mean corrosion?
I'm talking about corrosion resistance, exactly. Industrial environments throw everything at materials: moisture, chemicals, extreme temperature swings. Aluminium naturally forms this thin, tough layer of aluminum oxide when it's exposed to air.
Like a protective skin.
It's called a passivation layer. And that layer is highly resistant to more breakdown. That natural durability extends the lifespan of components, lugs, conduits, and closures, and that leads directly to reduced maintenance costs and fewer unplanned replacements.
So if we connect all this back to the bigger picture, this balance of performance, longevity, and cost savings is what's really redefining the benchmarks in electrical infrastructure.
Absolutely. It was probably cost and logistics that started the change, but the inherent performance is what has kept it in the lead. The why is clear, but let's pivot to the where.
Yeah, because the environments these tubes are in is where that corrosion resistance really shows its value. I was actually surprised by the sources detailing how integral this material is, especially in lugs manufacturing. I always pictured lugs as these solid, heavy pieces of metal, not something made from a hollow tube.
And that's a really common misconception because the tube is the precursor, the starting point. In electrical applications, these high-grade aluminum tubes provide strong yet light pathways for wiring, and they support efficient grounding and current distribution.
They're the go-to solution.
They're the trusted solution for dependable, long-lasting connections in power infrastructure.
And while our focus is electrical, the sources also highlighted its use in structural and mechanical systems. We're talking frameworks, piping, enclosures.
Right. Its formability and lightweight nature allow it to be easily integrated into precision equipment, especially where, say, vibration dampening is also a factor. That versatility is what makes it so useful.
And we specifically noted the reliance on high-grade aluminum tubes by manufacturers. The sources mentioned some high-profile aluminum lugs manufacturers in India who are using this material to meet these increasingly strict global safety and performance standards.
It's proof that this isn't a secondary material.
Not at all. It's foundational.
So now, let's drill down into why that material advantage translates into reliability in those two specific crucial areas: control panels and lugs. In control panels, safety and efficiency depend completely on thermal management.
That is the factor that gets overlooked so often. We all focus on power delivery, but controlling heat, that's the ultimate safety mechanism.
Exactly. I mean, think of a control panel as a tightly packed computer, but it's often dealing with hundreds of amps instead of a few watts.
A lot more heat.
A lot more heat. Aluminium's superior thermal management, its natural ability to dissipate heat quickly, is vital. It acts like a passive radiator. It prevents equipment failures from overheating, which is the #1 cause of downtime in a dense panel.
And I imagine the lightweight nature helps with organization, too.
For sure. Using lightweight aluminum tubing and channels lets engineers pack more into a smaller area. This gives you efficient space utilization, streamlined, compact, organized layouts, which is essential for automation and IoT integration.
So better use of aluminum in these structures reduces the risk of thermal runaway and short circuits.
It dramatically reduces those risks. It's not just about conductivity, it's about making the entire physical system safer and more streamlined by controlling the temperature and the footprint.
Okay, so that's panels. Now let's move to the lugs. These are the critical connectors that bridge heavy cables to the panels.
Right, they reduce energy losses, ensure uninterrupted power. The reliability of a lug, it all hinges on one concept: precision crimping.
That makes sense. An insecure connection is a high resistance point, and high resistance equals heat and, eventually, failure.
Correct. Imagine trying to force water through a kinked hose. All that pressure turns into wasted energy. In electricity, that waste is heat. The main advantage of using extruded aluminum tube for lugs is the precision forming. Manufacturers extrude these tubes to exact, consistent internal and external dimensions.
And that precision is what matters for the crimp.
It's mathematically essential for a successful crimp. When a lug is hydraulically crimped onto a cable, the tube metal has to compress uniformly around the conductor to create a cold, gas-tight fusion.
So if the wall thickness or the diameter of the tube varies even slightly?
The crimp will be weak. It introduces resistance, heat buildup, and ultimately system failure.
Ah, so the integrity of that connection starts long before the crimping tool even touches it. It starts with the precision manufacturing of the tube itself.
Absolutely. And the smooth surface finish of the tube also helps by reducing resistance and heat buildup at that connection point.
What's fascinating here is how the precision of the manufacturing process, just getting those tolerances exactly right, directly translates into the safety and longevity of the connection. The difference between a reliable connection and a fire hazard is literally measured in microns.
In microns, yeah.
That takes us perfectly into the engineering side. We've talked about the demanding tolerances. Now let's look at how these tubes are actually made and customized.
Right, the manufacturing process itself.
Yeah, how do they do it?
It all comes down to extrusion. And this is not a simple pouring process. It's a high-pressure molding process.
Okay. The sources described it as starting with top-grade billets of aluminum, heating them almost to their melting point, and then pushing them through a die to create those uniform, hollow sections.
And that consistency is the key. It's what ensures predictable mechanical and electrical performance. And this extrusion process is what allows for the huge variety in the form factor.
Right, which dictates the end use.
Exactly, and the specific load requirements.
Yeah, the source is detailed, the range of profiles available. You've got your standard round aluminum tubes, which are sort of the workhorse for wiring and cable management.
And then you move into the shapes that provide more of a structural backbone.
Exactly, the square and rectangular tubes. They give you strong load-bearing capacity and a compact design, often used for electrical housing where space is at a premium.
And then there are the specialized ones.
The seamless tubes, which are vital for high-precision applications, like in aerospace-grade controls, needing that perfectly uniform conductivity.
And of course, the ability to create custom tubes tailored exactly to a client's specialized system means manufacturers can innovate without being limited by standard component sizes.
But as we've stressed, the profile means nothing without rigorous quality control. We analyze those 4 key checks that manufacturers have to adhere to.
The non-negotiable.
The non-negotiables. First, dimensional accuracy, ensuring the thickness and diameter are precise for reliable crimping. Second, mechanical strength, so the material doesn't buckle under load.
Third is the surface treatment anodizing or powder coating for enhanced corrosion resistance that goes beyond just the natural layer.
And finally, the ultimate litmus test, electrical conductivity testing, guaranteeing that the material maintains its performance in power transmission, even after it's been treated and formed.
By adhering to those checks, aluminum tubes aren't just meeting old standards. They're setting the safety bar higher. And this dedication to quality really explains the material's rapid adoption.
Okay, so let's connect the dots. We know the material is superior. We know it's manufactured with precision. How does that translate across the major sectors? Let's start with the massive power and energy sector.
This is where cost-effectiveness really dictates scale. Aluminum tubes are used extensively in switchgear, transformers, distribution networks. The sheer volume of material needed makes the huge cost saving over copper an irresistible factor for global infrastructure development.
Right, without compromising performance.
Without compromising performance. Now look at automotive and transportation. Here the driver is weight reduction, pure and simple.
The EV push.
Exactly. The shift to electric vehicles is making lightweight materials mandatory. Aluminum tubes are widely used in electrical harnesses, battery enclosures, and control panels of modern vehicles, combining that lightweight property with the robust performance needed for high-voltage DC systems.
And that leads directly to the massive growth sectors of electronics and renewable energy.
Absolutely. Think about solar and wind farms. Electronics manufacturers rely on aluminum tubes in compact control panels and huge energy storage systems.
So the lugs and tubes are essential for getting the power from the panel or turbine to the grid.
And the lightweight nature also simplifies installation on these remote, structurally complex sites. It's a huge deal.
And even traditional sectors like construction and infrastructure are changing. Modern smart buildings rely on these durable and fire-safe aluminum tubes in their control systems to meet today's demanding safety standards.
So aluminum is far more than just a replacement for heavier traditional metals.
Right.
It is a fundamental component powering innovation for the future. It supports automation, maximizes safety, and improves performance in every sector, demanding both reliability and big steps towards sustainability.
So we've synthesized a huge amount of information pretty quickly. You now possess a detailed, synthesized understanding of why this humble aluminum tube is quietly the backbone of modern electrical infrastructure.
That means understanding those inherent engineering advantages. The exceptional strength-to-weight ratio that saves weight and logistics costs, the superior thermal management that ensures panel safety, and the role of precision extrusion in creating secure, long-lasting, low-resistance lugs.
So what does this all mean for you? It means when you see sophisticated industrial machinery or you read about the latest gigafactory being built, you now know that the quiet workhorse, the lightweight aluminum tube, is effectively supporting the entire operation.
Ensuring seamless flow and unmatched reliability from the smallest connector to the largest power grid.
Right. Now for a final thought. The transition to aluminum tubes inherently supports global trends toward eco-friendly practices by leveraging the fact that aluminum is easily and endlessly recyclable with minimal energy cost. Given that this material is so much more cost-effective than copper while still meeting and often exceeding essential performance standards, how far can this economic and ecological advantage push modern industries to adopt aluminium in other critical infrastructure-defining roles where traditional, heavier metals have historically dominated.
It really makes you think.
It's a trend that suggests we might just be living in the age of aluminum, even if we don't realize it.